Good afternoon, everyone. Thank you for joining us once again. Today, please go ahead and make sure that you have your notebook up to date. Lesson 9.01, Radian Measures for April 20th. Now, our primary measures for today is to understand radian measures as the length of the arc on the unit circle suspended by the angle. Now, we're basically going to be understanding how it is that we end up with radians from the pi, radians from the unit circle, and how unit circle and angles and pi and all of these things relate. Okay, so at this time, I would like you guys to head to the Think About It section, read through it, try to see if you can answer the questions there. And when you're done, I'd like you to come back to this video. So pause right at this moment and try to get through the questions. All right, welcome back. I'm hoping that you guys went through the question and you were able to complete it. If not, hopefully this will be um, a very good guide on how to get it done. So, first thing, as usual, let's draw our circle, draw our picture. Okay, so this is about 1, -1, put that at 1, and -1. We make our circle, something like that. Cool. And the first question says, what is a circumference? So to do circumference of a circle, circumference is equal to 2 times pi times r. All we have to do is substitute. It says that from here to here is 1 unit. So let's put in 1 for r. So circumference is equal to 2 times pi times 1. And that would be the same as just 2 times pi. Okay. So now we have the circumference. The second part says a radian is a unit of measure for an angle around a circle with a radius of 1. So same unit circle. Given it is 360 to rotate around a full circle, right? Already we know it's full circle. Let's measure 360 degrees. And your circumference found in part A, which is 2 pi. What would be the measure of a full rotation around the circle in radians? Okay, so simply put, the whole circle, or to measure all the way around, as we found the circumference would be 2 pi. So in other words, to get a 360 or full revolution, so 360 degrees, it would give you 2 pi radians. Okay. Maybe I should write out the whole thing. 2 pi radians. Okay. All right. Now, with that said, let's move on to part 3, which says, what could be the conversion factor from radians to degrees? Okay, so if you remember what a conversion factor is, a conversion factor is using a certain measurement that we already know and putting it into a fraction in order to convert from one unit to the next. So take, for instance, if we wanted to go from centimeters to meters, if we have 102 centimeters and we were trying to change that to meters, we would say our conversion factor would go 102 centimeters times a line, and would use our conversion factor, which we know to be is in 1 meter, there's 100 centimeters. So we would end up dividing these two. Centimeters cancel centimeters, and we would end up with 1.02 meters. Okay? In the same way, we're going to use that idea to set up a conversion factor. Okay? So if we know 360 gives us 2 pi radians, then in the same way, we know that 360 in 360 degrees, there must be 2 pi radians. Okay? Now we can break this down to make it simpler. 2 can go into itself one time, and 2 can go into 360 180 times. So another way of writing this would be 180 degrees over pi. Okay? So to go from degrees to pi, or from degrees to radians, you would use this conversion factor to do so, which is what we're going to do today. Okay? Now, hopefully, this has been helpful, and I will see you in class for the next part, which will be the I&M section. Hopefully, this was helpful for you. Okay, I'll see you in class.